In this video, I want to just briefly talk about data that you might be presented with in an exam. So what we have here is a graph that you might be given in the exam. We've got V here on the x-axis, I on the y-axis, so voltage and current. And this might be the voltage across a resistor, an ohmic resistor, and the current through that resistor. We've plotted a graph here, okay, with 4 different points, so 4 different values that we've taken in this experiment. And we know that this relationship should be a directly proportional relationship because the voltage and current through an ohmic resistor are directly proportional according to Ohm's law. So we've drawn a nice straight line because we know it should be a straight line relationship. Now, you may be asked here to comment on 2 things: the quality of the data in this graph, and you may also be asked to comment on the adequacy of this data. Okay, now in terms of the quality, what I would say here is these points, these data points are a long way from the line of best fit. They're scattered widely around the line of best fit, so that would suggest that this data is low quality data or poor quality data, or another way of saying it is these points are not very accurate. This data is not very accurate. So what you would need to do is go back, look at your experiment, try and find out where those inaccuracies have come in, try and find out the reason for any systematic or random uncertainties that may have caused these inaccuracies, and you need to address those before repeating the experiment. But the point is, all you might be asked to comment on here is whether the results are high quality or low quality, whether that data is high or low quality, and it is low quality because these points are a long way from the line of best fit and we know it must be or should be a straight line relationship. You then may be asked to comment on adequacy. Now, there are only 4 data points here, so this is inadequate data. It's not adequate. In order to plot a line of best fit and to spot a pattern, to find the correct pattern in results, you need to have at least 5 results, at least data for at least 5 different values of your independent variable. So this data is inadequate. In order to make it more adequate, you would need to find data for another value, at least one more value of your independent variable. And you could find that data. If you look, these are all the independent variable points. You could find the extra data somewhere between these values for independent variable points that you've got. So you might go here and find some data for that and plot it, or you could go for a higher value of your independent variable and find data for that and plot it, and that would make your results more adequate. Okay, so you need at least 5 points. So now if you had these points here, you could say that this data is adequate because you've got now 5 points there. Okay, but with the 4 it was inadequate. Let's have a look at another example then, just quite simply. If you had some points like this, okay, and you plotted a line of best fit through those points, let's just do that now. This might not be the best line of best fit just because of the awkward position I'm in here drawing this, but okay. In this example here, we would say that this is high quality data. Okay, so it's high quality data, and we'd say that it is adequate data as well. Okay, because there are 1, 2, 3, 4, 5, 6 points, and they're all very close to the line of best fit.